Okay, I want that all of you should interact. Okay, now today we are going to wind up the chapter. We will study electrical energy, electrical power, and also some miscellaneous topic that we will study today. And we will do some practice questions. And tomorrow will be very important session, because tomorrow we will be discussing most important questions of your previous year and also expected questions, sample questions of your NEET exam. Tomorrow we will cover whole questions from whole chapter of current electricity. So without any delay, let's begin with our chapter. Today we are going to study electrical energy and electrical power. So let us see. Now let us suppose we are having one resistor and its value is R, and let us suppose current I is flowing through it. Current I is flowing through it. Now we know that if current is I is flowing through it, then potential difference, we call it as PD. It will be equal to what? It will be equal to I into R, that we know by Ohm's law. And also we know that we have studied in electrostatics that V is equal to U by Q. We can write like this also here, U by Q. So from here we can write like this: U, energy, it was energy, electrostatic energy. So it is also called as energy. It is the energy, okay? But it was a formula of energy in case of electrostatics. But for if we put here potential difference, it will be our electrical energy. Okay, so we can write it like this: electrical energy is equal to Q. Okay, electrical input formula of Q is equal to IT here. What we will get? We will get U is equal to I square R into T. Okay, now what we got formula? Electrical energy is equal to I square R into T, and this is in the form of heat. Usually electrical energy in the form of heat. And also we can write like this: I square RT. We can write like this also here: what? V square by R into T. You know all this formula where it comes. Okay, and also VIT. You know now this formula. I'm not going in deep of derivation of it, because you can write like this here: I into R into I into T. You can write like this: V. You will get VIT. I have written VIT. And also if I substitute V is equal to I by R, I can substitute like this: I is equal to V by R, and put here, you will get this formula. Okay. Similarly, you must have studied all these things in your class 10th also. Okay, remember this formula. It is an important formula. Now here, how can question come in your exam? Let us suppose it is given that current is like this in your exam. How it can come? Suppose it is given that current is variable. Okay, current is variable like this. It is given like this: 2t plus 3, like this. And it is given that find electrical energy. Find electrical energy or heat energy dissipated. Okay, electrical energy is always equal to heat energy dissipated, because the electrical energy is wasted in the form of heat. So it will be equal to, how we will solve it? We will use integration. Okay, we will write like this: U is equal to I square. What is the formula of I? 2t plus 3, like this, I square R and then dt, and then integrate from 0 to t the formula, the time interval which will be given in the question. Okay, I will give one question. I will make a practice of this question also, this type of question. Okay, now let us I give you one example. First of all, you solve it. If I have a 10 ohm resistance and current is varying like this, let us suppose 2t. Okay, and it is also given that find heat energy find heat energy for dissipated, find heat energy dissipated from 0 to 4 seconds. Okay, try. All of you try this question. This type of question can come in your exam. Okay, try this question first of all. Try this question, all of you. All of you try this question. I give you 15-second time. Try, all of you, try. Any answer? Any answer from anyone? Any answer? Any answer from anyone? Okay, let us see. Let us see then how we can solve it. Let us see. We can write like this. We know heat energy H is equal to integration of dH is equal to integration of I square R into dt if we have a variable time varying current. Okay, let us see. Okay, Nandini got the answer. Okay, all of you should try. I square. What is I square? You can put here 2t whole square here into R. R is 10 into dt, and current is given as 0 to 4, and let us suppose energy 0 to H. We will get heat energy dissipated is equal to, okay, one answer also given. Okay, 320. Okay, let us see. H is will be how much? It will be equal to 0 to 4 integration. We will get 4t square. I think it will become 40 into dt. What is 40 outside? It will become t cube by 3. Limit from 0 to 4. If we put 40 by 3 into 4 ka whole cube, what we will get? 64. Okay, solve this. You will get your answer. Am I right, or I have done some mistake? Calculation mistake. Can you see, all of you? Am I right, or some calculation mistake? Can you see, all of you? All of you see any calculation mistake I have done? Okay, then this will be your answer. Okay. Okay. Any problem to anyone? Problem facing in integration or any concept, any step? Please discuss here. Any problem in any step? Please discuss here. Okay, good. All of you, Nandi, good. All of you, I want to interaction with from all of you side, from all of you should interact here. Okay. Now, let us see. I discuss with you one more concept, important concept. Now, I am discussing here about power transmission. Power transmission. Okay. Let us see how we know that electricity is produced in power plant. Okay, it may be hydro power plant or thermal power plant, nuclear power plant, like that. From there, through wire, we conduct electricity to towns, to companies, like that. What happens? We know. Let us suppose this conducting wire have resistance of RC. RC is equal to resistance of conducting wire. Okay, resistance of conducting wire. Okay, suppose it is coming to house. Okay, it is coming to house. Okay, what happens if it comes to a house? In a house, we are using different devices. Each device has some rating, like that. P is equal to VI. Suppose we purchase a fridge. It is written that 220 volt, like this. You can see it is written there like this. 220 volt and some like this, 220 volt, and suppose it is given like this, 150 watt. What does it mean? It means that if you will supply this much of voltage, it will consume this much of power. Okay, this is rating of a device. Okay, you can see this type of rating in bulb also. Some LED bulb, like that. It is written like that, 9 watt and 220 volt. Okay, these are ratings of the bulb. Okay, now we know that if these are ratings of the bulb, P is equal to VI, and now we know that suppose we are current is flowing through here through the connecting wire. Connecting wire, what will happen? Let me change the color of pen. Now we know that power consumed or power wastage in this connecting wire will be how much? It will be equal to I square into RC. Now what will be I actually the current reaching the house that we need, and we know according to device IP is equal to V into I will be equal to P by V. Now we know that if we put here I, what we will get? We will get P by B into whole square into RC. We can see that it is equal to P square RC by V square. You see, this is P square. It is power rating of a device. Power rating of a device. This rating, it is constant for any device. Power rating is constant. Okay, this is constant. RC, conducting wire. If we are connecting a copper wire or aluminum wire, its resistance also fixed. So it is also fixed. Only we see that V square is varying with power of power consuming connecting wire. What we see? We see here power wastage in connecting wire inversely proportional to V square. That means to reduce the power loss in connecting wire, what we have to do? We have to increase the voltage. That's why whenever we conduct electricity from power station to home, what we do? We conduct at a high voltage, maybe 33,000 volt, like that. We say 33 kV, like that. Okay, at high voltage what happens? It happens power losses become less. This type of usually comes, this type of question asked in your assessment and reasoning type. Okay, you should remember this. Why high voltage is used for conducting from power station to house to reduce the losses. Okay, any problem to anyone? Any problem to anyone? I've explained this because this type of question usually asked in your assertion reading type question. Okay, now let us move further. Let us move further. Okay, let us see. Let us see. Let us move further now. Okay, let us see first limitations of Ohm's law. I know we have studied Ohm's law in our previous lecture also. What is Ohm's law? We have studied like this. The Ohm's law was V is equal to IR, and we have studied like this. Here it is V, it is I. We have seen that Ohm's law means this. This type of device are called linear elements. Linear elements. Linear elements. Okay, or we say it as ohmic conductor, ohmic material. Okay, it follows Ohm's law, V proportional to I. That's why we call it as ohmic material. Now, what is limitations of Ohm's law? Suppose first limitation. We know some metals, some materials, it may be some superconductor also. Some superconductor also. What happens that at a high temperature, what happens? They are not following this relation, rather than they deviate from this path like this. So after some certain temperature, V is proportional to I, this relation fails. Okay, this is first limitation of Ohm's law. Okay, at high temperature. Okay, second limitation. You will study at the end of the physics of class 12, you will study one chapter of semiconductor. You will study there some devices of semiconductor like diode, transistor. You will study that diode and transistor, they are having a VI graph like this. You will study there VI graph like this. If you have studied in your school, you must have remembered. This is also non-linear. You see here, non-linear. It is also non-linear. That means non-linear. That means non-ohmic. Okay, it is also non-ohmic, not following Ohm's law. Okay, third example, let me take third example. One material is gallium arsenide. It is usually used in solar cell. It is used in solar cell. It is also having some this type of behavior. Okay, not varying linearly. So what we say, it is also a non-linear element. Okay, it also not obeys Ohm's law. So we have seen there are three examples of non-ohmic conductor, and these are limitations of Ohm's law. Any problem to anyone? Any problem to anyone? Any problem? Anyone? Any problem? Okay, let us move further then. Now, we came to know V is equal to IR. Now, first question, what will be the dimension of R? Can you find, all of you? What will be the dimension of R? Can you find, all of you, to find what will be the dimension of R? Find, all of you. You know R will be equal to V by I, and V is equal to U by Q. You can find here energy dimension ml2t minus 2. Q dimension means I into T. You can solve it like this. M L2 T minus 3 and I minus 1. This is V. You put it here. M L2 T minus 3 I minus 1 and then divided by I. You will get the answer. ML2 T minus 3 I minus 2. This is the dimension of R. Okay. Okay, all of you. Okay, all of you. Yes. Now, one more question. Try this. Try this, all of you. Before that, I teach you one concept. Suppose we know that V is equal to IR. That means R is equal to V by I. Suppose we are having VI graph. Okay, we are having VI graph like this. We know that VI graph and V by I is equal to R. And in VI graph, V by I, what it represents? It represents slope. That means tan theta. If suppose you take this as perpendicular, this as base, and this is angle theta, what will write tan theta? Tan theta is equal to perpendicular by base. You see, perpendicular will be some voltage and base will be some current. You can write like this, V by I, and this is called as slope. So we know that V by I is slope and it is equal to R. So we can say that slope of VI graph gives what? R. Okay, or we can say R, or we can say we know that R is equal to, one more thing we know that R is equal to 1 by G conductance. So we can say slope of VI gives R or 1 by G. Similarly, slope of IV graph, if I is present here and V is present here, so we can write slope of IV graph will give G or 1 by R, because we know R is equal to V by I and G will be equal to I by V. Okay, any problem? Anyone, any problem? Anyone, any problem here till here? Any problem? Okay, now let us see one question. Let us see one question. It is written IV graph. Suppose we are having resistance R1, R2 and R3. You have to find the relation which will be greater. R1 is equal to R2 is equal to R3. B is R1 is greater than R2 is greater than R3. Find out the answer. I will be waiting for your answer. Fine. ABC, find out the answer. What will be the relation of resistance? Any answer from anyone? Any answer? Okay, option C. Let us see. You see here, more slope is here. You see, slope of R1 is greater than slope of R2. Slope of R2 greater than slope of R3, and we know slope of IV graph means conductance. G1 is greater than G2 is greater than G3, and in term of resistance it will be opposite, R1 less than R2 less than R3. Okay, so C will be answer. Okay, all of you, rest all of you should interact. Okay. Now, let us see. If suppose we have two bulb connected like this. If it is a 100-watt bulb, it is 60-watt bulb. What we did, we connected it with some voltage, and second case in parallel, and second case we are connecting like this, 100-watt bulb and 60-watt bulb, they are in series, and we have connected it with a voltage V. We have to find in A and B which bulb will glow more. Okay, try this. Which bulb will glow more in A? Which will glow more? Think. Okay, I am telling that in A, which will glow more, 100-watt or 60-watt? Which will glow more? Which will glow more? Try this. Okay, then let us see. We know that first of all, you should remember one thing. This is the rating of a bulb. This is rating of a bulb. Okay, so we are not concerned about these are the rating of individual bulb. Okay, this is external voltage. Okay, we know one thing, P is equal to V into I, like this. One more thing, or we can say V square by R. For any bulb or any device, individual rating and pressure are related like this. Pressure is inversely proportional to R for any device. Okay, we say that for a more power device having more power, its R will be less. So we can say like this, since 100-watt has more power, so we can say that resistance of 100-watt is less than resistance of 60-watt, like this. Okay, now we know that we have come to know this. Now when we are applying external bias, see here, we are telling like this, V dash, this V dash, see V dash, this voltage was the initial rating of this device, V and V, like this. Okay, now we have applied some voltage V dash. We know that power due to external bias, we know that P will be V square by R. That we know, this external voltage we have applied. And why we are using this formula? Because both will have same voltage across the ends. So we are, to compare them, we are using this formula, V square by R for first one. this one, and for this one also we can apply like this. P2 is equal to V square by R. Now you see, for first one we are having 100 watt, and for second one we are having 60 watt. We know this one is greater as compared to this, so its power loss will be less. You see here it is less, so it will be more. So what we see? We see that for this one more power will be used. That means more glow. More glow. Why? Because these bulbs, more power means more glow, because they are based on heating element. That's why more power means more glow, so it will glow more. And also you know that in our house also we are having parallel connection, and we know when we will use 100 watt bulb, it will glow more as compared to 60 watt bulb. That's why common sense also we can say. Okay. Now let us see here. What we know in series connection, both will have same current, so we will be using same current formula. Here also one thing, same thing. 100 watt bulb resistance will be less than 60 watt bulb resistance. Now we know that power is equal to I square R. Since I is same, we are using this formula. From here we can say that power is related to R like this. Now we will say that since 100 watt bulb has a low resistance than 60 watt bulb, we will say power of 100 watt bulb will be less than power of 60 watt bulb. That is power consumed, power wasted in losses in heating. More heating in 60 watt, that means it will glow more, because these devices are based on heating element. So more heat losses means more glow. Okay, so when we are connecting in series, then 60 watt bulb will glow more as compared to 100 watt bulb, and when we are connecting parallel, then 100 watt bulb will glow more as usual, but here it will get reversed. Any problem? Okay, I will explain once more. No problem. I will again. Okay. I will explain once more. Let us see. Okay. See here. You see here. You know this thing. These are formula from for individual devices. We know for individual devices, when they are fabricated, when they are built, at the same time these ratings are done, and according to these ratings we know P is equal to, we use like this, it is written like this: 100 watt and 220 volt, 60 watt and 220 volt. We know P is equal to V square by R during their making, when they are prepared and when they are manufactured. What happened? More power means less resistance. Like this I have written more power, less resistance, like this. Now to use the formula, we know we have three formula. P is equal to V square by R, P is equal to I square R, and we have P is equal to V into I. We use this formula when we are talking about parallel connection, because parallel and the voltage is same. We use this formula when we are dealing in series connection, and this is also a general formula we can use. Okay, for series we use this formula, and for parallel we use this formula. Okay, what we do here, we can see that same current are flowing through this, so we will use this formula. P is equal to I square R. This is the resistance of bulb. Okay, you can see this power is losses in form of heat, and you see this bulb will glow more when more losses occur, because they are based on heating element. We are talking about that bulb which are based on heating element. Okay, for heating element bulb, what will happen? More losses means more glow. Okay, what we will see here, power is proportional to R. You can see here more R is present in 60 watt resistance than 100 watt resistance. So more resistance means more power loss and more glow will occur here as compared to 100-watt bulb. So in series, this will glow more as compared to this one. Okay. Okay. Any problem till now? Any problem? Feel free to ask anything. Getting confused? You should ask. The more you will ask, the more I will do. I will tell you. Okay. Okay. Or getting confused? Getting confused? Hmm? Okay. I tell you once more. Don't get confused. I tell you once more. See here. See here once more. Once more, see here. What happened? We are having 100-watt bulb and 60-watt bulb. Okay. Let us see. They are having some voltage like this. They are having some rating like this. 220 volt like this. They are having some rating like this. Okay. Now, when they are having some rating, we came to know during their manufacturing, we use this formula P is equal to V square by R. What we come to know? R is equal to V square by P. V is usually in India it is used as 220 volt, and we see that more power, less resistance. You see here, more power is 100 watt, and see more power, less resistance. So we can say like this: resistance of 100-watt bulb is less than resistance of 60-watt bulb. Having any problem here? First of all, you ask step by step. Now, second step. This information we get during the manufacturing of the device. Okay. Now, when we have purchased this and when we are using it like this in our household, what will happen? We know if we have connected in series, what will happen? Current I will flow through them same. And you know, when current I flows same through them, then we use power loss formula like this. P is equal to I square into R for comparison, because we can compare for both of them current having same. So power will depend on resistance, only resistance, because both have same current. If we will apply here, P1 is equal to I square R. Okay. And also here P2 is equal to I square R2, because current is same in both of them. What we came to know? We came to know that power directly depends upon resistance. Power directly depends upon resistance. You see here, and we came to know during the manufacturing resistance of 60-watt bulb is more. So more resistance means more power losses, more energy losses will occur at 60-watt bulb. Okay, as compared to more electricity consumption will occur here than 60 watt, than 100-watt bulb. Now what will happen? You suppose when we are connecting, this will consume more power, means it will glow more. If it is consuming more electricity, more power, what does it mean? It means that it will glow more as compared to this. This will take less current, less, it will glow more less as compared to 60 watt. Okay. Any problem to anyone? Got it or still having confusion? Okay. Okay. Okay, then let's move further then. Okay. Let's move further then. Okay. Now, let us see some question. Let us see some question. Then we will go through some question. Let us take now. Take this question. Try this question. We are discussing this question. I give you 15-second time. All of you should try this question. Try this question first of all. All of you should try this question. Try this question, all of you. Try this question, all of you. Any answer? After solving this question, I think your concept will be clear now. You will get a concept clear. Any answer? Okay, let us see then. Let us see. Solution. What will happen? You see here, it is telling that one electrical bulb marked with this much. What is the rating? Okay, let us see then. Option A. Nandini is telling option A. Let us see then. An electrical bulb marked like this, a 40 watt and 220. This is the rating of the device. You see, this is the rating of device, and it is decided at the time of their manufacturing only. Okay, now let us see what will happen. What will happen according to it? What will be resistance? We can write like this: R is equal to V square by P. From here we can decide. Okay. Now it is telling that like this also. It is telling that it is used in another circuit having a voltage of 100 volt. Now what will be its power? We know that P is equal to V square by R. This formula we are using. Okay. Now we can say that since it is only telling about power and voltage, we can say like this: power is for first one. For this one, we can say that we can say like this: for first case, P1 power is 60 watt. Okay, 40 watt is equal to voltage is 200 volt by R. In second case, power is we have to find is equal to given voltage is 100 volt by resistance will be same. It is decided during the manufacturing. It will be same for the device because same device is used at this voltage. Okay, so resistance will be same. So if we will divide this both of them, what will happen? P by 40 is equal to 100 by R into R by 200. You can solve it, and I think you will get the answer. Power will be you can get here. I think some mistake I have done. Some mistake you can see here. Power by 40 is equal to 100 by R. R by 200. Okay. This will be 2. Okay. 20. Power is equal to 20 watt. Okay. What was your answer? Option D. Am I doing mistake or am I right? Any calculation mistake I have done here? You see here. Any calculation mistake I have done? Okay. Oh, good. Okay, that's it. You see what is the formula? Power is equal to V square. Okay, good. And V square. Use this formula. What we will get? Calculation mistake. This was the calculation mistake part. What we will do here? You can take the ratio of both of them. What we will get? We will get 40 by P is equal to 200 twice by R into by R into R by 100 times twice. Okay, we will get here what? We will get P is equal to 10 watt. So answer will be A. Okay, all of you, any problem to anyone? Now we will dealing with question. Okay, so be attentive. Take your copy pen and try with me along with me. Okay, all of you. Any problem to anyone? Any problem to anyone? Try anyone? Okay. Okay. Let's move. All of you. I need all of you should interact with me. Now try this question. All of you try this question. All of you try this question. All of you try this question. All of you. Any answer? Anyone? Any answer? Anyone, any answer? Okay, let us see then. Okay, let us see then. Let us see. Let us see. We are at, first of all, see, three bulbs are arranged in series with this. Okay, no problem. Three bulbs, they are connected like this. Okay, and they are connected 40 watt, okay, 60 watt and 100 watt like this. Okay, they are connected with 1 to 20 volt. Okay, which will have minimum resistance. Remember, resistance, we have to find the resistance of the device, individual device. We have no need of this. It will not depend on the external resistance, no dependency. Only it will depend upon the ratings of the bulb of the device. Okay, now if it depends upon the rating of device, what does it mean? Suppose we know that P is equal to V square by R. What we'll say? We'll say R and P are inversely opposite to each other. Okay, the device having more resistance, more power will have less resistance. So we can say this one having more power, so its resistance will be very less. So we will say it will be greater, it's greater than 60 watt, and more gets most greater is 40 watt like this. So the resistance of the 40 watt bulb will be more than 60 watt bulb than 100 watt bulb. Okay, so minimum resistance which will be, it will be of 100 watt. Any problem? Anyone, any problem? Anyone, any problem here? Anyone, any problem? Okay, okay, okay. All of you, all of you, all of you should interact, okay? Now, let us see this question. Try, all of you try this question. Try this question. I give you 50-second time. All of you, take out your copy pen, try this question. Don't see it, don't see it. Try this your question, try your question like this. Type your answer. Take it like test. Okay, try this question. Any answer? Any answer? Anyone? Okay, let us see then. Let us see. It is a very simple question. What will the see here? Okay, let us see. Okay, okay. Anjali got, I see. C got B. Okay, let us see. These are the ratings. Okay, these are ratings of device. These are ratings of device, and they are divided. They are decided at the time of manufacturing. Decided at time of manufacturing. When they are manufactured, they are decided like this. They are independent of external resistance. They are not depending upon, not depends upon external resistance, external voltage. We can apply 220 volt, 250 volt, but it is telling that when we will apply 250 volt, it will consume 50 watt of power. Okay, it is the meaning of it. Now let us see, it is marked like this. Okay, now how much current will pass through it? Okay, so current will be, how will you find it? We know P is equal to, relation is V into I, because we are knowing power and voltage. So I will be, power is 50 watt and it is 250. We can solve it and we will get the answer. Okay, I think it will be B only. Okay, I think it was a simple question. Okay, all of you. Okay, now let us see this question. All of you try this. All of you try this question. Yes, all of you try this question. Okay, good. All of you try this question. I give you 30-second time. All of you try this question. All of you try this question. All of you try this question. Any answer? Any answer from anyone? Any answer from anyone? Any answer? Any answer? Yes, one answer came. Okay, let us see. It is the question. It is telling that three equal resistors connected in series across a source EMF together to dissipate this much of power. It is telling that we are connecting three resistors. That means R is equal to, that means R equivalent will be equal to 3R, like this. Now, what for this power dissipated is 10 watt. Now it is telling that when they are, what will the power dissipated when they are connected in parallel? Okay, parallel, then it means R equivalent will be now R by 3. Now we know that one more thing, that power, we know one more thing, power is equal to how it is how it is related to voltage. You see here, they are connected to a same source. It is written here, they are connected to a same source. You look here, if they are connected to a same source, we can write like this: P is equal to, we know, V square by R. That means we can write like this: if we are connecting, we are finding the power in parallel by power in series, we can write like this: V square same by resistance in parallel by V square same by resistance in series. This will be cancelled because same path, same source given here. You can write like this: RS by RP, and you know here RS is 3R. Okay, 3R, and parallel we know R by 3. What we get? We get power for parallel by power for series. It will be equal to 3 square. Got it? From here we can find the answer. But I came to know one general formula for this type of question: power of parallel connection by power of series connection, ratio of them, it is equal to n square, where n is number of resistors, for this type of question. Okay, for what we will do, you put here as 10 volt, 10 watt. You can find the power of parallel. It will be 10 into 9. It will be equal to 90 watt. I think answer will be D. Any problem to anyone? Any problem? Any problem to anyone? Okay. All of you good. All of you should interact. Okay, I usually wait from all of you. Okay, but only Nandini is responding always. But I think all of you should respond. Hmm? Okay, let us see further. Try this question, all of you try this question. This is a good question. I think this is a very good question. Try, all of you try this question. Try this question, all of you. I give you 30-second time. All of you try this question. Try this question, all of you. Answer K. No. Option is not. You have to find. Okay, there are two cases. They are not option. Okay, see it clearly. They are not option. Okay, see it clearly. Yes, see it clearly. They are not option C clearly. Any answer from anyone? Got it? I give you 5 seconds more. Try this question. 5 seconds more. Try this question. Okay, let us see then. No problem. Let us see then. Here, let us see. Now, first of all, we assume here, I write here like this. Okay. Case 1. What is the case 1? Let us suppose it is open. Switch is open. Switch is open. Okay. It is open. Okay. If it is open, what will happen? This will circuit will be like this. All three will be in working mode like this. Okay, all three will be in working mode like this. Okay, and we know identical bulb, that means R, R, R. Resistance will be same. So we can write here for this R equivalent will be equal to 3R. And also we came to know it is it's, let us suppose this voltage is V, it will be also equal to V, it will be also equal to V. We will say like this, VA is equal to VB is equal to VC is equal to V. Like this, you see here, they all are same. You see here, voltage across VA, VB and VC all are same. We can write like this, it will be equal to, we are supplying how much voltage? You see here, supply voltage is V. V divided in 3 parts. How much? V by 3 here, V by 3 here and V by 3 here. Okay, now it will be how much? V by 3. Any problem to anyone? Similarly, we can write like this, power dissipated in A will be equal to power dissipated in B will be equal to power dissipated in C, and it will be equal to how much? We can write like this, V square by R. V square by R means this much voltage. You write like this, how? V by 3 whole square by R. R is how much? You see, for each resistance has voltage this much, and R is, you know now, each resistance for RA is equal to RB, for is equal to RC is equal to R. Okay, what we will get? We will get it will be equal to V square by 9R. Now, this is power, and this we have to compare power and illumination like this. So we have come to know here power. Okay, now this was the case when we have switches open. Now we assume case 2, and case 2 we assume like this. Here switch is closed. Switch is closed. What is happening? Switch is closed. If switch is closed, this becomes short circuit. This becomes useless. Okay, now what happens? What happens like this? R, you see here, RA is equal to RB is equal to R. It remains as it is. Now VA is equal to VB, and it will be equal to V by 2, because this V voltage is now divided into parts only, here and here. That means V by 2 and V by 2. Like this, we can say power dissipated through A will be equal to power dissipated through B. It will be equal to V square by R. That means V by 2 whole square by resistance R. How much we will get? We will get here how much? You write here. It will be equal to how much? V square by 4R. Okay. Now, what we can do? We can do that. You see here, compare. You see here. You see here. See this one. It was power when switch was open. This is the power when switch is closed. If we multiply 9 here and 9 here, you can see here like this. It becomes the power of the circuit when switch is closed, which switch is open. We can say like this, new power is equal to 9 by 4 times old power. You see here, Old power was this much. I have compared with this. So how much increased? 9 by 4. Or you can do like this. You can take ratio of both of them. This is equation number 1 and equation number 2. You can take ratio of both of them. You will get this value only. 9 by 4. Any problem to anyone? Any problem to anyone? That means new case we will glow more. It will glow more. It will be more than old because 9 by 4 means 2 point something. That means twice of old power. Okay, that means it will glow more now. Okay, anyone, any problem? Okay, I explained once. I explain it once. Okay, let us see. Let us see it once more. Now, let me see. Let us see. Now, there are two cases. You read this question once. Okay, read this question once. Question is telling that we are having three resistors A, B, and C, and like this A, B, and C, and is telling that A, B, and C. You see that it is telling that if this switch is open, it is open. Now, if it is open, that means all three will be active. Now, if all three are active, that means total resistance will be 3R. You see, I written here 3R, and also each resistance will be active. That is equal to R. Okay. Now, voltage. We know we have supplied here voltage V. V here. All are in series, so voltage will divide three parts. So each part how much? V by 3, V by 3, and V by 3. Okay. Now we know that power dissipated in A, power dissipated in B bulb, and power dissipated in C bulb. Here A bulb, B bulb, and C bulb. Power dissipated is equal to V square by R. We know this formula. Now we came to know for each bulb how much voltage there available. This much voltage square by R. We came to know this is the power dissipated, or we can compare like this. This is also proportional to illumination, brightness. More power means more brightness. Okay, see this. This was the first case. Similarly, when switch is closed, this one is closed, this one is closed. When we short here, what will happen? This will become useless. Now only two resistance left. So we will write like this: RA is equal to RB is equal to R, and voltage will be how much? Now V voltage is dividing into only two parts. Then each will get V by 2 and V by 2. You see here. Okay. Now power consumed in each resistance, in each bulb, will be how much? V square by R. This is the value of V. This is the R. You get here. What we get formula? We get here how much? V square by R. You see here in the last step what I have done. You see here in the last step what I have done. I rub this part and show you once. Okay, what I have done, you see once. What I have done here, you see what I have done. I have used here okay. Wait. Okay. Now see, we got the power this. Now this is the new power. This is the new power for through each resistance. How much each will wasted through each bulb. We have to compare this much, this power with old power. This was the old power. So what we have did, we see that divided 9. So we multiplied here 9 and divide by 9. We know when this will be the old power. You see old power. So we write here new power will be equal to 9 by 4 times old power, or we can say like this 2.1 times of old power. That means what we are seeing? We are seeing that in the new case, what will happen? More power consumption, twice of the old power, or we can say more illumination. In the new case, bulb will glow more because they are consuming more power. So they will glow more. as compared to this one. Okay, so illumination, what we will say? We will say more illumination in second case and more power consumption in second case. Okay, got it or still have any confusion? All of you, anyone, any problem from here? Anyone, any problem? Okay, then see this question. Try this question. All of you, I give you 10-second time. Try this question. All of you, take 15-second time and try this question. All of you try this question. Try this question. We have solved this. Okay. Now this question. Try this question. All of you try this question. Try this question. All of try this question. Any answer? I think you should do it. You can do it this type of question. Just formula putting, I think. I given, time given, energy given, H is given. You have to find the value of V. You know this formula, energy is equal to VINT. Okay. Okay, use this formula, you can solve it. Okay, I think you can solve it. Okay, very simple question. All of you can solve it. All okay, all of you. Yes, yes, good. All of you should try this. These are basic questions. Take this question, try this question. Try this question. Try this question. I will not answer this question. No answer. I will not answer this question. I have discussed this concept in the theory part only. Any answer from anyone? Any answer? Anyone? Any answer? Anyone? Yes, answer came option C. Okay, all of you should answer. All of you, it is telling that two electrical bulb, 60 watt and 100 watt, they are connected in parallel. See, they are connected in parallel. Okay, one more thing we know, resistance of 60 watt bulb is greater than resistance of 100 watt. Okay, this we know. Okay, now they are telling that they are connected to a same source like this. It is telling that which will draw more current. You know one more thing, that they are both are having same voltage. Voltage is same here. We know that V is equal to IR by Ohm's law. Voltage is same. That means I is depending upon R. Voltage is same. That I is depending upon R. That means I is inversely proportional to R. If voltage is same, we can write like this. So resistance more, current less. You see, by common sense also, more obstruction then less current. More obstruction, less current. Less obstruction, more current. Okay, you see, 60 watt has more obstruction. 60 watt has more obstruction. So less current through this path. Okay, through here. So here current will be less and here current will be more. So we can write here A and B. A is 60 watt and B is 100 watt. A will draw less current. A will draw less current. A will draw, you see here, both draws more current than NO. This D answer, A draws, okay, wrong. B draws more current. B is 60 100 watt bulb, it will draw more current as compared to A. Okay, so answer will be A only. Okay, okay, let us move then. Try this question, all of you. I think this you can try. Okay. Okay. Okay, we are having. Okay. Questions are there. Okay. We take this question. Okay. Take this question as your homework. How we will try this? I tell you one more thing. You know, power is equal to energy by time. You see, power is given. Okay, and it is telling that after certain time, what happens? Temperature is increases to 100 degrees centigrade. After how much time is required to form 100 gram steam? You know one thing. You first try this question. If you are having some concept of heat, use this and try this question. First of all, you all of you try this question. I will give you homework for you. Try this question as homework. Okay. Okay, all of you try this question as a homework. Take this as a homework. If you will get any problem, you can ask with me, discuss with me. Okay. Take this question as a try this. It is also simple question. I think it is also a simple question. All things are given. You see here, all things are given. Okay, all things are given. This one take also as your homework. Try this question as a homework. Okay. Try this one also as a homework. Take this as your homework. Okay. Yes. Should I spirit? Okay. 2 electrical heater. Okay. This one also homework, because they are a same type of question. So we should not waste time in this type of question. Take this question as your homework also. Also okay. Yes. You should take this type of question as homework. They are simple question. This one question also. Okay, try this question once. Try this question once if you want to try. I tell you one more thing. It is a same thing. It is given that we are having 3 power. This one, and this one. Okay. What it is telling? You try this question. All of you try this question. I will discuss. Try this question. Try this question. Any answer? Now, let us see. It is given that it is the rating of the device. This one rating, this one is also the rating of device. Okay. From here, you can find the resistance R1 and R2 here. Okay. You know, there is one trick only. Here you see. It is telling that find heat generated per second. This one, it means heat generated per second. That means it is asking about power. You have to find the power only. Okay, okay, they are connected in series. That means find the R equivalent is equal to R1 plus R2. Okay, and power is equal to V square by R equivalent. V square is given, it is connected to this much volt. Put here V square, R equivalent you can find from here. Put this and you will get the value of formula this much joule per second or watt. Okay, this will be your answer. You can find it. Any problem or I should solve it? Any problem to anyone? Any problem? Solve, sir. Okay. I solve it. I solve it. I solve it. See, I solve it. You find an R1. What will be R1? R1 will be equal to, you see from here. We know P is equal to V square by R. Then R1 will be how much? V square by P. V square means 220 into 220 by P is 60 watt. It is R1. R2 is equal to what? V square by R. V square by P. V square means 220 into 220 by how much power? Power is 40. We got here R1 and R2. Okay. R equivalent. They are connected in series. We will get R equivalent how much? We will get here R equivalent is equal to how much? First of all, you can solve like this. R1. I will tell you one shortcut also here. R equivalent is equal to 220 into 220. It is common. You see here. It is V square and it is V square. We can write like this. It is V square by 60 and it is also V square by 60. We can write like this. V square, okay, into 1 by 60 plus 1 by 40. Okay, it is 40. This we got value of resistance. Now, what we will do? We have to find the power. Power is equal to how much? Power is equal to, we know, V square by R. You see here, V is also 220 volt. If it will be different, then we can put it different here. But V square is the same. So, V square and R equivalent, we got how much? V square into 1 by 60 plus 1 by 40. Solve it. How much you will get? You will get, take LCM, 40 into 60 comes and numerator, and 40 plus 60. It is 100. You will get here 24. Okay, 24 watt or 24 joule per second. Okay. Any problem to anyone? Now, I tell you one thing. I tell you one more thing. Okay. I tell you one more thing. See, whenever you have resistance in a device in parallel. For parallel, you can write like power also like this. Directly you should use this, or you can find like this. Using this. You remember this. V square, same, you take common and you can put like this, or you can do like this. You see, for a power, for series connection, what happens? Power, use this formula. Directly you can solve it, because if it is different, then it can differ. So you should use this step only. Take V square common and then use this formula. It will be always applied. Okay. Use this formula. This is also very much useful and very shortcut. Use this one only. Okay. That shortcut will not be applied if here is another voltage than this. So I will suggest you that you should apply this one only. Okay. Okay. See this question. I think this is very easy question. Read this. Read this question. If you find it is okay. Okay, now this question. All of you can try this question. All of you. Yes. Yes. Yes, you should try this question. Now take next question. Okay, try this question. I give you all of you 30-second time. Good question, try. All of you try this question. Try this question, all of you try this question. Any answer you got, then you can answer the question. I think this is the last question of today's session. So do it patiently. Try this. Let us see. Okay, let us see. Let us see. Okay. It is telling that two unequal sections R1 and R2 here are connected across two identical. See here, two identical cells. You see here, identical cells are present here and here. You see here. Now, can thermal energy be equal? Developed will be equal. If yes, then find the condition. Okay. Okay. You know, if same resistance, same voltage is applied here, same internal resistance also, we know how much current will flow through it. We know I1 will be how much? I1 will be E by R1 plus R. And here I2 will be how much? I2 will be E by R2 plus R. Okay. Now we know that how much heat energy passed through it. We know that heat energy will be how much? It will be equal to I square RT. I square RT. We can say like this. I square RT means E by R plus R. I square into RT. R1 into T. Okay. Here. Second case, heat will be how much? E by R2 plus R, that is I square into R into T. Equate all both of these equations. H1 is equal to H2. What we will get? We will get how much? E by R plus R square into R1 into T is equal to this formula R. Sorry, yeah, here it is R1, then R2 plus R whole square R2 into T. Cut here. Solve this equation. What you will get? Solve this, you will get some relation, I think. What you will get? Take root both sides. You will get root under R1 by R1 plus R is equal to root under R2 by R2 plus R. Take cross multiply. What we have to find? We have to find the condition. If you will cross multiply, what you will get? You will get one thing. Root under R1 into R2 plus root under R1 into R is equal to root under R2 into R1 plus R into root under R2. Solve here and find the value of R. You will get the value of small r as root under. This is the standard relation. So I am writing here. It is this one. This is the standard. You can get from here. Okay. You put that side, take LCM and then find out the R. You will get this relation. This is the relation for this type of circuit to have same heat energy. What it should be? It should be relation like this. R should be equal to under root R1 into R2. This is the relation, standard relation. So you should remember this. And after solving this, you will get this relation only. Okay. Any problem? Or I should solve it? Any problem? Any problem to anyone? Okay. Okay. So this was the last question of our today's session. Remember, tomorrow's session will be very important for all of you. All of you. It will focus on your NEET exam only. I will cover the question from day 1 lecture to now today's lecture. All the question of different types asked in your exam, or it can be asked in your exam based on NEET pattern only. Okay. So don't miss tomorrow's lecture. It will be very much important. Okay. Tomorrow we will wind up the chapter and we'll take more and more questions. Okay. So good night. Take care and keep your study going on. Okay. We will meet tomorrow. Then Any problem from to any from any side? Anyone has any problem? If you have any problem, you can ask before ending the session. If you have any problem, okay, no problem then. A good night and take care and keep your study going on. Okay.